In this video, I will walk through 3 practice problems of how to use Newton's second law of motion. So before we jump into these practice problems, let's first cover what is Newton's second law of motion. Well, that's this formula right here, which says that the net force acting on some object is equal to the mass of the object times the acceleration of the object. So let's see how we can use this formula to solve a few different problems. So let's check out our first problem. This says, find the acceleration of a 15 kilogram box that has a 500 Newton force applied to it in the right direction. So let's go ahead and sketch this out really quick. We have this box. It weighs 15 kilograms. And we're told that a 500 Newton force is pushing it in the right direction. So we'll say our force is 500 Newtons. Now, our question is, what is the acceleration of the box given this information? So we're just going to use this formula right here, and we need to solve for A. So notice we know the net force, that's 500. So here's what we can write. 500 must be equal to the mass of the object. So we're told the mass is 15 kilograms, so let's say 15, and we're trying to find A, so 15 times A. So all we have to do to figure out the acceleration is divide both sides by 15. So when we do that, these 15s cancel out. We're left with A is equal to 500 divided by 15. That turns out to be 33.3 repeating. So this is our acceleration. Now our units for acceleration are going to be meters per second squared. Now, when we write acceleration, we should always specify in what direction is that acceleration. So in this case, we're told that this force is pushing the box towards the right. So we'll say the acceleration is this value to the right. So that will be our answer for this one. All right, let's check out example number 2. It says find the acceleration of a 3 kilogram box that has a 25 Newton force applied to it in the right direction and a 55 Newton force applied to it in the left direction. So let's sketch this out. So we have this 3 kilogram box, and we're told a 25 Newton force is pushing it in the right. So let's say, we'll call this force 1. The first force is 25 Newtons. It's pushing it to the right. Our second force is 55 Newtons, and that's pushing it to the left. So we'll say, let's call that force 2. That's pushing it to the left at 55 Newtons. So once again, we want to find the acceleration. So we're going to use this formula once again. But notice that on the left-hand side, the net force, we need to figure out what is that net force. So here's how we can do that. The net force, to find that, all we're going to do is just add the two forces together that are pushing on the object. Now, in this particular case, we have two forces, where the first force is pushing in the right direction. So we're going to call the right direction a positive direction, and we'll call the left direction a negative direction. So when we're adding the forces together, we'll say 25 plus this 55 right here, we're going to say this is a negative value since it's going in the negative direction. So we'll say plus negative 55. Or in other words, 25 minus 55, that turns out to be negative 30. So our net force is equal to negative 30. We could say newtons if we wanted to. So now we know the net force, we know the mass of the object, that's 3 kilograms, and we just have to find the acceleration. So we'll say negative 30 is equal to the mass is 3 times a, the acceleration. So to solve for a, we'll divide both sides by 3. Negative 30 divided by 3, that turns out to be negative 10. So we'll say a is equal to negative 10. So this is our acceleration, a negative 10. Remember we said the left direction, we're going to say that's the negative direction. So another way of saying that is that a is equal to a positive 10 in the left direction. So for our final answer, let's write a is equal to 10, again, meters per second squared, and we'll say left. So it's in the left direction. That's the direction of the acceleration. So that's our answer for that one. All right, let's check out our very last example. A 795 kilogram car starts from rest and travels 41 meters in 3 seconds. How much force did the car engine provide? So this question's a little bit different. So we have this car, and it's 795 kilograms. That's the mass of the car. And we are told that it travels 41 meters. So this distance is 41 meters over the course of 3 seconds. So let's say t is equal to 3. So this question is a little bit different. So we can still use Newton's second law of motion. In this case, we're trying to find the force of the car. So we're given the mass of the car, that's 795, But before we can use this equation, we need to figure out what's the acceleration of the car. So to find the acceleration of the car, we're going to refer back to one of our kinematic equations that we learned early on in physics, and that is the displacement of an object is equal to the initial velocity times time plus 1/2 times the acceleration times time squared. So what we're going to do with this equation is we're going to figure out what is A, what is our acceleration. So let's go ahead and do that. So the displacement of the car, that's 41 meters. That's how far it traveled from start to finish. So we can say 41 is equal to, now notice that it says the car starts from rest. So our initial velocity, this value right here is 0. So this whole quantity is actually 0. And then we have plus 1/2 times A. So let's say 1/2 times A times time squared. Time is 3. So 3 squared is 9. So we'll say times 9. So 9 times 1/2, that's 4.5. So let's go ahead and just write 4.5 times A. Or 4.5 times A. So to solve for A, all we have to do is divide both sides by 4.5. And we find that A is equal to 41 divided by 4.5. Turns out to be 9.1 repeating. So now that we figured out the acceleration, we have everything we need to figure out the force, the net force. So how much force did the car engine provide? Well, that would be the net force is equal to the mass of the car, which is 795, times the acceleration, which we just found was 9.1 repeating. So 795 times 9.1 repeating, that comes out to about 7,243.3 repeating. And we're talking about force here, so that will be newtons, will be our units. So that was an example of how you can solve for the net force of an object. We just needed to know this key kinematic equation to actually figure out what the acceleration of the object was. So those were just 3 quick examples of how to use Newton's second law of motion.